The Kieran Islands are a relatively small archipelago, predominantly made up of tropical rainforest and grassland, and approximately the size of New Zealand, that is situated in Serina's southern hemisphere during the late Thermocene, roughly midway between the South Pole and the equator. Situated perfectly between South Ankiska and Stevlandia to the west, and Walteria and Kari to the east, it exists on a tectonic plate entirely its own and has been isolated for more than 150 million years, since before life was introduced to Serina. The island was moved southward through the eons since. Now near the South Pole, it gradually migrated from a northern location in the Hypostacene to an equatorial one in the Cryocene, sparing it from significant climate change that affected mainland ecosystems. Though it has shrunk in size over the years through the process of erosion, and recently been further by rising sea levels, never since the introduction of life have the islands ever come into contact with another landmass. Like Borea in the late Thermocene, most animal groups which arose on mainland continents have never touched foot on the Kierans. Uniquely, however, is that unlike the recently recolonized Borea, the Kieran Islands have had an unsurpassed 150 million years for life to evolve in such an isolated state. Most animals on the Kierans can be found nowhere else. Though there are more recent immigrants from distant mainlands, carried by freak storms or oceanic adaptations, here numerous bird lineages still exist which have evolved in situ, from the earliest canary colonists, for 150 million years in brilliant isolation from the rest of the world. There are again no vivas here, nor cerastriders, nor any other terrestrial megafauna so familiar on the larger continents, which were at one point connected. No, here in the Kierans, life has produced forms arguably even stranger. Elephantches. Above sunrise in the Kieran Islands reveals a community of strange creatures beginning their day in the meadow. A large browser plucks small, sweet fruits from the tall branches of a tree with the aid of a pair of strange, dexterous tentacles upon its snout. Just behind, a pair of smaller grazers, exhibiting their own smaller version of the same appendages, pass by. These strange, trunked birds, collectively known as elephantches, are the most prominent large herbivores across the archipelago that is the Kieran Islands. Moving silently through the dark understories of the forest of the Kierans, as much as trotting conspicuously in great herds upon its savannas, are many species of large, flightless bird. From a distance, many might seem relatively ordinary. Like many birds which have evolved in island habitats rare in predators, they have lost their wings. Like the emu, the ostrich, or even the aardgoose across the ocean, they're largely plant eaters, and they brood their eggs in the usual manner ancestral to Serina's birds, and utilized by most on Earth as well. There are no live-bearing avians here. But a closer look at any one of these birds on the Kieran Islands will quickly reveal an attribute of these particular animals which is as wholly unique to them alone in the entire bird order, just as the evolution of live birth was in the vivas. Where on most other birds could be found a hard, keratinous bill or beak, on the elephantches it is instead replaced by a fleshy snout. This alone isn't a wholly unique feature, though it has evolved only twice in birds, for it is similar to that of a ceralope. Utterly unique to the elephantines alone, however, are an additional two mobile tentacle-like appendages. In fact, extraordinary extensions of either nostril. These are utilized by the creature for myriad purposes, bringing food to the mouth, grooming, social display, even as a pair of snorkels for use underwater. Indeed, the paired trunks of the animals are certainly far more effective manipulators than the forearms which the group has long since lost, so much so that the elephantines seem not to miss their wings at all. Small and fast-running forms utilize their nasal appendages in place of their wings, spreading them to the side to aid in their balance, whilst lumbering giants, twice as tall as a man and many times heavier, use them to pull down the branches of trees to secure succulent fruits and buds which would otherwise remain beyond their reach. Surely the one thing more interesting than the ways that the elephantines utilize their unique nasal appendages, however, is the history which led an initially ordinary colony of canaries, just like those anywhere else on Serina at the start of the Hypostacene, to go down such an evolutionary path, to come to produce such an aberrant innovation. How, most people surely would be inclined to wonder, did the elephant get its trunks? To find out, we must go back to the beginning, just a few million years post-establishment, when the life on the Kyrans was still largely alike that across the rest of the world. Elephantines, a natural history. 150 million years ago, perhaps 1 million pairs of domestic canaries of all breeds and colors were freed into the newly planted grasslands of a young Serina, and from there on out, things would never be the same again. The canaries were released in groups of about 1,000 across approximately 2,000 release sites to cover all habitable land. At least one of these releases occurred on the Kieran Islands. A yellow domestic canary, similar to those introduced to Serina, including the Kieran Islands 150 million years ago. Like many small birds marooned on islands before them, the Kieran canaries quickly adapted to exploit the resources of their new habitat. Flight, for many, became unnecessary without predators to worry them, and many birds rapidly developed proportionally smaller wings and larger bodies. 1 million years post-establishment, a plump, mostly herbivorous canary with reduced flight capabilities. Like many other birds of this early time, even with few predators, it has reverted to a dominant natural coloration over many generations of breeding, which has largely removed most recessive color morphs. A total loss of flight was the inevitable next step for many birds, and due to the isolated nature of this particular canary colony's habitat, it would remain relatively free of terrestrial carnivores for far longer than those on the mainlands, permitting the long-term survival of this first wave of early flightless birds. 2 million years post-establishment, a flightless, entirely terrestrial quail-like bird has evolved, which feeds on both plant and animal foods it can forage for on the ground. A variety of groups would soon radiate from these primitive ancestors, including large herbivores, defenseless creatures not terribly dissimilar to the womblers, and similar early giants which evolved in mainland environments around the same time. But these birds were not the ancestors of the elephantches. No, this group would not stake claim on these niches for many more millions of years. At this time, their ancestors were headed down a very different evolutionary path, not as herbivores at all, but insectivores. 5 million years post-establishment, one lineage of flightless canary, now larger and longer of leg and bill, specializes towards feeding on insects, particularly the soft-bodied sorts that it can scratch out of the leaf litter of bamboo thickets and grass tussocks. There were many birds competing on the Kieran Islands by this point, however, and resources once abundant were now limited. To avoid competition, this particular lineage of canary gradually began to forage by night, when most other birds were inactive. With sight of less use, its bill became longer and more sensitive to touch, so that it could be probed into the soil in search of worms and burrowing insects and locate hidden food sources. In effect, they came to resemble a Serina kiwi bird. The wings became smaller still until they were totally vestigial, while the eyes, less necessary, became smaller, and its vision less acute or sensitive to color. To avoid predators now during the day, they begin to shelter in crude burrows. To dig these, the foot claws became larger. 15 million years post-establishment, a nocturnal insectivore with poor eyesight but an acute sense of smell and a long, sensitive beak. Once this niche was established, it was highly successful, providing a springboard for the further evolution of adaptations suited to finding food without sight. In some, the eyes became smaller still, while the bill developed an extra sensitive covering of soft, rubbery tissue, retaining a hard nail only at the tip to grasp prey dug out of the earth. The legs became more powerful, and the claws especially large and curved, suited to digging out large burrows in which the young could be raised to protect them from new predators and a slightly more temperate climate during the Tempestine. The bill becomes broad and flattened as a shovel to move soil loosened by the claws, while whisker-like bristles appear on the face, further increasing the tactile sensitivity of the bird as it burrows and searches for food. 25 million years post-establishment, a badger-like bird has evolved, well suited to digging and finding food underground. Its eyesight is now almost vestigial, able to sense light and dark and movement, but little more, while its sense of smell is especially acute, with the nostrils having migrated toward the end of the snout. It is now exclusively active under cover of darkness. Birds like this persisted in similar form for a very long time, having found a successful niche otherwise unoccupied by animals on the isolated archipelago. Some gave rise to the snuffalo, a huge herbivore that used its large bill to walk, but some forms were destined for more long-term success. The first of what would become this later dynasty evolved fleshy cilia along the tip of the bill, made of the same rubbery tissue that otherwise covered all but the very leading edge of the beak. These were connected directly to the nerves of the snout, giving the bird even greater ability to detect and capture prey by sensing the vibrations produced by burrowing worms and insects in the ground. The legs grew shorter and the body longer to move better through tunnels. Its tiny eyes give it vision that is heavily blurred and extremely nearsighted at best. But even these birds were not entirely without sight. The strange burrower, with its fleshy, finger-tipped bill, lasted many millions of years beneath the feet of the larger dominant fauna of the islands, changing little until a tragedy befell their world, giving it its time in the sun. 75 million years post-establishment, the bird is now almost mole-like and rarely comes above ground. Its wings have been totally lost, without even internal remnants to show they ever were. Using its noodle-like nose appendages to pick up ground vibrations, it hunts for worms in elaborate underground tunnels, but also forages above ground at night. 80 million years after their colonization, a freak natural disaster would change evolutionary history upon the Kieran Islands forever, as an asteroid approximately 600 feet in diameter strikes the largest island in the archipelago. Not large enough to cause lasting worldwide harm, small asteroids have struck Serina fairly frequently over the course of its history, usually crashing into the sea or burning up before reaching the ground. Due to the specific location of the Kyran impact, however, the event was highly destructive on a local level. Though the asteroid burnt up considerably through Serina's atmosphere, it was still sizable at the time it reached the ground. The impact created a shockwave sufficient to level most of the forests on the island and kill or maim any animal caught in the open across most of the region, except for those which were sheltered underground. The asteroid event effectively extinguished more than 90% of Kieran's endemic bird diversity and all of its megafauna. The burrowers inherited the islands. Most of their competitors wiped out, if not by the impact itself, then by the resulting loss of food and cover due to the loss of the island's forests. The formerly nocturnal and largely subterranean birds were able to expand their horizons. Their eyesight quickly improved after a number of generations bathed in the sunlight of the surface world, but the reversion occurred too late for one aspect to be restored: color vision. Being entirely useless in the dark, the cones required to pick up colors were long ago lost, so that even once the birds became terrestrial and diurnal again, they remained colorblind. Nonetheless, as the forests recovered and birds began to arrive from distant offshore isles, some of the former burrowers remained, growing larger and adapting adaptations used in their former niches in new ways. The fleshy nose appendages mostly disappeared, but the bill itself retained its rubbery and flexible covering. Muscles had developed in the upper jaw, which were able to move their snouts while rooting for food, and this continued to be the initial way that the former burrowers found their food above ground. Their diets became more generalist, incorporating tubers, seeds, and fallen fruit in addition to invertebrates. Gradually, they started to pick food from the plants themselves. The soft tissue on the upper jaw extended past the edge of the beak. Forming a mobile lip, able to reach up and grasp food from branches above their heads. The beak itself became regulated to a broad plate on the upper and lower jaws. All food was swallowed whole. The first true elephantines, megafaunal terrestrial birds with flexible noses, can be said to have appeared around 90 million years post-establishment, 10 million years after the asteroid impact event, though the exact form to be considered the first is largely an arbitrary distinction. 100 million years post-establishment, one of the most basal elephantines, here a badger-sized bird which spends all of its time above ground, feeding mostly during the day. Its claws are still large, but now blunt and hoof-like. Its nose is long and flexible, and though it cannot see in color, it has developed obvious black and white markings on its face for communication. The eyes are larger, and the whiskers on the face are reduced in size and number. It feeds on a variety of food which can be found in or on the ground or on low bushes, including fruit, nuts, worms, and birds' eggs. From here on out, the elephantines diversified substantially, becoming the Kieran's most prominent large herbivores, though many species are still actually opportunistic omnivores. One group adapted its digging claws into ungulate-like hooves, specializing to feed on the open savannas and to flee newly arrived predators in the form of giant flightless shorebirds distantly related from stiltskins, which colonized the island's impoverished ecosystem at the same time as the elephantines. But most importantly, they further adapted their noses. To reach higher food sources in the trees, their snouts became longer and more mobile. All the while, their nostrils remained at the very tips of their snouts, as they'd been in the burrowing ancestor. With the snout's interior already divided by two distinct channels, it was fairly easy for the nostrils to separate at their tips, eventually producing some forms with two distinct and fairly dexterous trunks. Trunks served several purposes. They could be used to reach food and to manipulate the environment, but also provided a huge area of surface for the olfactory receptors, allowing elephantines an unrivaled sense of smell. They could be used to reach food and to manipulate the environment, but also provided a huge area of surface for the olfactory receptors, allowing elephantines an unrivaled sense of smell. The hollow chambers were highly conducive to amplifying sound. Many of the group additionally developed a hollow crest from the upper jaw and extending to the back of the head to resonate their calls for communication over great distances. The bills of elephantines were now totally covered in soft, muscularized tissue, with horny portions of the beak only present at the tips of both jaws, where they were used to crop vegetation. The jaws themselves were, however, lined with small keratin teeth known as tomia, which also occur in earth waterfowl, and were the predecessor to the proper teeth of the ceralopes. Tomia were useful for cropping grass and leaves, but their avian jaw structure inhibited an ability to grind the lower jaw back and forth to chew their food, meaning it has to be swallowed whole. Certain elephantines got around this and developed a mechanism to masticate their food before swallowing it by sliding their upper jaws forward on a hinge from the cranium. All birds exhibit a degree of cranial movement. It's particularly obvious in earth parrots. Elephantines can thus grind their food to a pulp before swallowing it, aiding the primitive, non-ruminating stomach to break down coarse plant foods. Unlike ceralopes, however, which also chew, but through a different mechanism, namely a muscular, toothed tongue in the roof of the mouth. Elephantines do not have cheeks, and their method of eating is thus not as efficient, as some food may spill from the mouth during the chewing process. Even so, the end result is a net gain in efficiency versus simply swallowing their food whole. 150 million years post-establishment, two modern elephantines with mobile trunks, hollow crests used to amplify sound, and herbivorous diets. On the left is a large browser, down the right, a little grazer. The grazer shows a more basal appearance and could reasonably be used to demonstrate the form from which the left animal arose. Like their ancestor, even though these species cannot see in color and are thus colored in natural shades of grays and browns, they use bold black and white markings on their heads for purpose of display. Snuffles. Though the most impressive, the ancestors of elephantines were not the only of the Kieran Islands' nocturnal burrowing canaries to survive the early Thermocene asteroid impact event. The numerous members of this lineage were all among the most fortunate of the island's wildlife, for by sheltering below ground in their dens, many were saved from the most damaging shock waves, though of course, those whose burrows unfortunately lay directly at the site of impact were to be not so lucky. As the island's ecosystem recovered, some of the soft-snouted burrowing birds gradually abandoned their nocturnal way of life, giving rise to the elephantines. Others, however, changed far less in the same time. Snuffles are 6 species of small to medium-sized nocturnal birds, in some respects superficially resembling shaggy brown ducks, but entirely without wings and with long digging claws on the hind legs, which have changed very little from the ancestral form of the elephant. They diverged between 30 and 40 million years post-establishment, sometime after the evolution of a sensitive fleshy snout, but before the lineage evolved musculature to support a mobile nose. All living species are still active only at night and dig large underground dens in which they raise their young and roost during the day. Their eyes are very small and they are nearly blind, and the face still supports long, bristle-like whiskers to serve as guides and keep their owner from bumbling into obstacles. Like the ancestors of the elephant, they leave their burrows after sunset in small groups to root around in the mud and the leaf litter with their wide, shovel-shaped bills, feeding on earthworms, crickets, beetle larvae, and whatever fallen fruits and seeds they stumble across. Snuffles' nostrils, like those of elephantines, are situated at the very end of their bills, and they find their food through a combination of scent and touch as they snuffle, otherwise quite blindly through the dark understory of the Kieran's rainforests. A family group of lesser snuffles, each about as large as a white domestic duck, forage for food in a forest clearing. Normally feeding in complete darkness, here they find themselves bathed in a beam of cool blue light emanating from the large gas planet which Serina orbits. The largest snuffle is also the most herbivorous and feeds significantly on fallen fruit. It can grow as large as a medium-sized dog, as much as 40 pounds in weight, and produces burrows which would be wide enough to accommodate the entrance of an adult human being. The smallest snuffle, on the other hand, grows to only about 4 pounds, the size of a kitten, and eats almost exclusively invertebrates. Most other species range from 10 to 20 pounds in size and are generalists with varied diets, feeding on anything organic they find while rooting in the dirt. Snuffles are more intelligent and exhibit more complex social lives than might be expected. They mate for life and rear clutches of 2 to 4 eggs in underground nests. Both partners maintain the den, incubate the eggs, and feed the young for the first few weeks until they are able to leave the nest. Though snuffles begin foraging for food at 1 month of age, they stay with their parents for as long as 8 months, and in some species will often even remain in their natal groups after the next season's eggs are laid, assisting in rearing their younger siblings until they decide to venture off and begin their own families sometime in their second year. Another surviving group of burrowing, soft-billed birds, somewhat closer down the line to the true elephantines, but nonetheless still separated by nearly 75 million years of evolution, are 2 species of especially interesting aquatic birds known as water snuffles. Though not truly allied with their land-living distant relatives of the same moniker, having diverged at least 30 million years later, they are broadly similar in their basic form. Small eyes, sensitive whiskers, and acute sense of smell, differing more in their habits. Water snuffles, as their name suggests, are adapted to find food underwater and have become excellent swimmers, with their hind legs situated at the end of their bodies and evolved into large paddles. Nostrils are borne on short, extendable stalks, akin to the earliest trunks of the elephantines, but likely independently developed. They serve to allow the animal to surface and breathe without fully emerging its head. Water snuffles exhibit the same mobile snouts and a fan of finger-like fleshy appendages at the tip as the early elephantines, having diverged later than the terrestrial snuffles. As in their ancestors, these improve their sensitivity to hidden prey buried in the mud and are able to feel around to detect buried prey items which, once discovered, are quickly gulped down whole. Even the shells of armored mollusks are broken down in the gizzard through the aid of gastroliths. Water snuffles still rest and raise their young in burrows, and retain sharp claws with which to dig them, usually dug into a riverbank and opening only underwater to protect them from terrestrial predators. Propelling themselves with large webbed feet and digging out worms and shellfish from the sediments at the bottoms of the Kieran's freshwater rivers and lakes, the water snuffles have evolved into something very much like a truly avian analog to Earth's platypus. A least water snuffle weaves its way through a vegetated stream. The 2 living species, the least and the greater water snuffle, are distinguished mainly by their preferred habitats. The more abundant least water snuffle, an animal around the size of a mallard, is most often found in slow-moving ponds and streams choked with water plants. Its eyes are small, and it feeds on a wide variety of aquatic insects and crustaceans, as well as mollusks, which it is particularly adapted to handle with a wide gape and large, muscular gizzard. Greater water snuffles, which are marginally larger, prefer fast-flowing, clear bodies of water and feed mainly on benthic fishes and crustaceans such as shrimp, both of which are usually pursued rather than dug out from the sediment. Their eyesight is thus better than that of the lesser species, and the tendrils on the snout are shorter and thicker. For most of the Kieran Islands' history, there were very few ground-based predators, and the great majority of flightless birds had only aerial threats to fear, namely falconaries and predatory seabirds. Of these, few were active at night, resulting in many birds of the Kierans becoming nocturnal, including the soft-billed birds. Before the asteroid strike, the Kieran Islands supported a large number of moa-like herbivores which, in turn, were preyed upon by several very large flying predators, including an eagle-sized falconary with a 15-foot wingspan. These giants unfortunately died out with the extinction of the large animals which had evolved to predate upon. As soon as the ecosystems on the islands had recovered, however, vagrant birds from both east and west again began to colonize the Kierans. Many types of primitive songbirds, waterfowl, and rail-like birds had established themselves by 90 million years post-establishment. Around the same time, the soft-billed, burrowing birds were beginning to produce their first large, surface-living representatives. One new migrant in particular, though, would significantly alter the island's ecology. Around 95 million years post-establishment, 55 million years from today, a large species of fish-eating, stork-like bird reached the islands from South Inkiska to the west. It supported an impressive 10-foot wingspan and stood as tall as a man, with a long spear-shaped bill. Though evolved as a riverine predator, it was immediately the largest carnivore to be found on the islands. It had little trouble adjusting its diet to one made up almost entirely of land animals, as it found a smorgasbord of small flightless birds, and the chicks of large flightless birds easy pickings. Though formerly migratory, the Kieran Islands offered a year-round supply of food, and flight became less and less important as the majority of their food could be captured on foot. These new colonists evolved over several million years into a fairly diverse assemblage of flightless, ground-hunting predators known as takarewera, a Maori word literally translating to demon storks, and they would live up to this title. All manner of small, flightless birds were pressed now by this new and highly effective predator group. Some were to die out, unable to redevelop sufficient defenses before being literally eaten out of existence by the new invasives. It was suddenly very disadvantageous to lose flight, and from then on out, the vast majority of new colonists to the islands would keep their wings. But what of those birds which had lost theirs entirely? the flightless, soft-billed birds, ancestors both of snuffles and elephantches, were now pressed into two very different directions. The more primitive burrowers were now forcibly kept in their ancestral niches, for with predators now among them, they were likely to fall prey if they abandoned the safety of their nocturnal habits and the shelter of their burrows. For those elephant ancestors which had already abandoned these habits before the appearance of predators, however, the only available response, if they were to avoid predation, was now to become larger and to do so rapidly, or to become faster. The storks were long of leg, but they were not adapted to run at high speeds. Rather, they stalked fairly slowly through the grass or the undergrowth, keeping watch for movement and ambushing their prey from above. They were additionally adapted to merely grab and swallow their prey whole, not to tear meat, something they could not do if you were too large to fit in their mouth. Early elephantches quickly produced a number of veritably giant forms following the arrival of the storks, while other groups grew long and lean, adapted their claws into shock-absorbing hooves on the tips of their toes, and specialized to outrun their enemies. But evolution is an arms race. Just as the island's herbivores evolved ways to escape their predators, the predators too adopted new forms and new behaviors to circumvent their prey's defenses. This isolated island would no longer be a refuge to its native inhabitants from the tooth and nail world beyond its shores. They had been infiltrated by invaders from far-off lands, animals which played by very different rules. Lanks are giant taquereweras with an extremely slender build, the largest specimens of which are able to reach heights of 20 feet or 6 meters. They are the largest of the Kieran's predators, and indeed, the tallest animal found on any of the Kieran Islands. Lanks are exclusive carnivores that prey on almost anything they can swallow whole, and with a bill which can grow to nearly 6 feet in length, their diet is very broad indeed. Like some pterosaurs were believed to have done in Earth's past, they most often feed by stalking slowly through tall vegetation and grabbing any small animals that they disturb as they walk. Lanks are one of the few predators which feed heavily on the Kieran's numerous flightless, burrow-dwelling birds which emerge from their nests at dusk, and to make use of this prey resource have adapted to be most active for the few hours around sunrise and sunset, resting in thickets for most of the day and on the darkest nights. Lanks will also occasionally prey on animals too large to swallow whole by using their bills as a spear and then smashing the prey item against the ground until pieces small enough to swallow can be torn from the carcass. Lanks usually feed in pairs, which may work together to flush small prey, or more rarely, to bring down larger animals, usually separating their young ones or picking off those which are unwell and unable to keep up with their groups. Lanks are predominantly animals of open environments, their size inhibiting ease of movement in dense jungle. They are particularly commonly observed hunting along the very edges of forests and thickets, where they can take advantage of small prey animals that leave their corner at night to feed in the clearings. Two lanks hunt in a meadow just after sunset. One has succeeded in capturing an unfortunate snuffle just as it emerges from its daytime resting place. Though it protests admirably, it can do nothing to halt its attacker from swallowing it alive. Its snuffling days are over. The nocturnal call of the lank is one of the most iconic and eerie sounds in the Kieran Islands. Pairs are highly territorial and defend the borders of their territories with low-pitched songs consisting of many varied rising and falling notes. Upon hearing another pair's song, other couples in adjacent territories are encouraged to respond. The calls carry for considerable distances on clear nights, so that across many of the Kieran's grasslands, sunset is marked by an otherworldly chorus of alien bird song across the islands. To any small animal in the vicinity, there are surely few sounds more frightening, and even herds of large herbivores freeze and stand motionless when the haunting songs begin. Lanks nest in patches of brushy vegetation and lay a single egg. The resulting chick requires more than a year of parental care before it can feed itself, and will not be ready to breed for 10 years. It may, however, then live into its 80s, for it has no predators of its own. Bone beaks are 3 species of takarewera native to the Kieran Islands, which share a common ancestor to the lank, but have evolved down a very different line. Whereas the lank is slender and tall, the 3 species of bonebeak are stocky and muscular, with especially powerful beaks, usually lightly colored and topped with a horny crest, which are adapted to biting and bringing down large prey. The bill is sharply serrated toward the front to slice flesh, while exhibiting broad, flattened ridges toward the back, which are specialized to hold bones and crack them with the especially well-developed jaw muscles. Bone beaks are short and fairly heavy-set birds with large heads and fairly thin legs. Nonetheless, they are rapid sprinters and are capable of keeping pace with the cursorial elephantines that make up most of their diet. Their wings are smaller than the lanks, but not totally vestigial, performing a function in maintaining their owner's balance while running. To kill prey, a bonebeak attempts to side up to it and bite it around the neck, just behind the skull. The bill hooks downward at its tip, and thus catches a firm hold as it pulls the elephant to the ground and crushes down on its vertebrae, breaking its neck or incising its windpipe. The largest bonebeak can attain a height of 8 feet and a weight of 300 pounds. Working in a pair, it can prey on most other animals in its environment, including the largest elephantines, and is an apex predator of the Kieran Islands, alongside the lank. The other 2 species are considerably smaller, in the range of 1 to 200 pounds, and somewhat longer-legged. These are better adapted to catch and feed on faster-moving prey. All species, however, are avid scavengers and are able to make especially good use of carcasses, as they are the only animals on the Kieran Islands capable of crushing bones to consume marrow. The two smaller bone beaks, native to the North Island and South Island respectively, may occasionally be cannibalized by their two larger relatives. The giant bone beak, which ranges across the islands, however, has no predators. Even the equally widespread lank gives it a wide berth, for though it is far taller, it is much more delicately built. A male and female South Island bonebeak feed on a freshly caught white-cheeked gazellefinch. The several species of gazellefinch, plains-dwelling and grazing elephantines of the Kieran savannas, make up the majority of prey for the two smaller bonebeaks. The largest species prefers heavier, slower-moving prey. On the Kieran Islands of Serina, 150 million years post-establishment, there dwells one group of birds very different from anything else on the island. They are entirely without feathers, and their skin is instead protected by a layer of beaded and reptilian scales and scutes. A large claw originates from the fused tip of the second and third fingers, and the hind legs are highly bowed outwards from the body, giving these most unusual avians a semi-sprawling stance. They are small, sluggish creatures which feed on plants, the specific vegetation varying with the species, and they are cold-blooded, wholly unable to maintain their own body temperature and reliant on their external environment to keep warm or cool down. They are, of course, the descendants of the mucks of the early Thermocene, arboreal scale birds which evolved in the jungles near the equator of Serina's western supercontinent. These birds presumably reached the Kieran Islands many hundreds of miles offshore from their ancestral home by rafting, perhaps on large mats of fallen trees and other vegetation carried down rivers and into the sea by tropical storms. Aided by their slowed metabolism, and likely able to graze on their rafts even as they blew across the open sea, the scale birds would prove highly successful colonists when some, by luck, reached the eastern shores of the Kierans approximately 35 million years ago. They would find abundant tropical vegetation, fewer predators than upon the mainland, and an equable tropical climate that varied little throughout the year. Some would remain tied to the trees as capable arboreal climbers that browse the highest leaves and shoots in the jungle canopy. Others, however, would broaden their diets to ground vegetation, and from there, to waterside plants. Today, one of the most abundant scale birds on the Kieran Islands is the maritime muck, a very aberrant bird which has come to both behave and closely resemble the marine iguana of Earth's Galapagos Islands. Like marine iguanas, maritime mucks have specialized to feed almost completely on the algae which grows in abundance on the rocky coasts of the Kieran Islands, where currents bring rich nutrients to the island shores. The wings of the maritime muck are broadened into paddles useful for propelling them through the water, but retain their large claws to pull themselves up the stony sea cliffs they dwell on, while the hind legs are large and powerful to grip the slippery, algae-covered rocks both above and below the surf. Growing up to 30 pounds but maturing slowly, only adults, mostly males, of several years of age can carry sufficient mass to be able to dive underwater to graze without immediately becoming chilled. The youngsters and smaller adult females only feeding on algae exposed during low tide at the edges of sea. Maritime mucks crop most of their food by turning their heads sideways and scraping low-growing algae directly from the rock faces, either above or below water, with the serrated edges of their bills which form a clean cutting edge, though will opportunistically browse on free-floating algae in similar flora as well as the kelp-like seaweeds abundant along the sea coasts, which grow to great length up from the sea floor with winding leaves and tendrils. These latter food sources provide more nutrition and are much more easily consumed, but are more difficult to reach for all but the largest and most powerful swimmers, except in cases where storms may wash large quantities of seaweeds onto the shore, attracting huge mobs of the birds, both small and large, which gather to gorge on the windfall of salad. To best aid in absorbing solar energy and warming themselves as quickly as possible after spending time in the cool water of the sea, the maritime muck is invariably a dark gray or brown color, dotted with patches of green and, in mature adult males, purple iridescence along the head and neck. Young are often darker than adults, for it is even more imperative they warm quickly due to their small sizes, and indeed hatchlings, which are totally independent from the time they leave their eggs, are often completely black in coloration. This coloring also aids in providing them camouflage against the dark rocks of their habitat. Maritime mucks, like all scale birds, practice no parental care and bury their eggs in soft sand near the sea coast, using the sun's heat to incubate them. As with other animals that follow this parental method, the young usually hatch simultaneously and must run a gauntlet of predators, which on the Kierans include tacareweras, especially the lank, seabirds, and large terrestrial crabs, before reaching the relative safety of the rocky seashore. Though they will never recognize their parents, the young mucks will associate closely with the adults for protection, often resting on their backs, which their strictly herbivorous elders seem to mind little, if at all. The maritime muck is indeed the most social of all its kin, living in colonies numbering in the millions across the shores of the Kierans. At first, this might seem simply to be unintentional response in a normally solitary animal to a large food source that must be shared in order to be accessed. But the creatures also behave in ways which suggest an intentionally social aspect to their behavior has evolved that is absent in their ancestors or close relatives, in order to best survive and glean the riches of their rather harsh and very unconventional habitat. Maritime mucks are frequently seen roosting in huge colonies on high cliffs at night, huddled to conserve their body heat and alert one another to the approach of predators with several distinct alarm calls, a different one each for a marine, terrestrial, or volant threat. In response to a sea predator, such as a sword whale or a porpoise, the birds emit a deep, raspy bark which is more easily heard underwater and which causes the entire colony to flee the water in a panic, scrambling up the rocks and to a high point above the crashing surf, where they gather and turn to face the threat, keeping a watch until it appears to have moved on. Threats from land or air are announced with higher pitched screeches and are escaped from by dashing into the sea. If caught on open ground, the maritime muck is highly vulnerable, unable to run quickly, and can only hiss and attempt to claw its attacker. If cornered in a rocky area, however, the muck can often very successfully escape into a crevice and exert enough force against the walls of its hiding place with its wings and arms that even a very determined predator will have a hard time pulling it out. While able to swim, the muck is not agile in the water, and is perhaps most vulnerable when crossing expanses of open water between rocky islets to reach food sources. Another reason only the very largest individuals will leave the safety of the shoreline.